Welcome, students. Well, this week we are going to make a little recipe because we're going to talk again about units, but a very, very special unit for chemistry, which is the mole. But leading up to that, I'm going to do a little demo because I'm really craving peanut butter cookies. This is my favorite peanut butter cookie recipe. First of all, because I'm gluten-free and I can't have flour. And second of all, because it is like the easiest recipe out there. Have you guys ever heard of 3-ingredient peanut butter cookies? Okay. This is the easiest recipe, and it demonstrates a few different ways that we might measure ingredients, and it will give you a demo of why we might care about units. So first of all, I need 1 cup of sugar. So I'm going to open up my sugar here, and if I need a cup, I could measure by individual grains of sugar. You know, if you looked at them under a microscope before, we know they're little different crystals of sugar. So I could measure out, I could count them. What do you think? How long will it take me? I looked it up. It would be 220,000 individual crystals of sugar, approximately. We're going to be here a while. I think that's 3, 4, 5. So we're not going to do it that way. I'm going to use a cup, right? So 1 cup of sugar will give me 220,000 approximately grains of sugar. That's going to be a lot faster. So the next thing I need is 1 cup of peanut butter. So I can measure peanut butter with a cup, but it's messy. I don't really like doing it with a cup. So instead, I'm going to use a scale. And I have a scale here that can measure grams of peanut butter or ounces. So you remember the whole thing about ounces and pounds and fluid ounces versus whatever ounces. My mom had a little saying that she used to tell me that a pint's a pound the world around. So I could say if I want 1 cup of peanut butter, I know that that's 8 ounces, 8 fluid ounces by volume, and that's about 8 ounces by weight. And I could go to grams and say that's about 220 grams. But I know that peanut butter is pretty fatty, so it's actually lighter than water. And I looked it up and it's actually more like 240 grams. So I'm gonna put my bowl on the scale, and if I press the tare button, it will go back to 0. So I'm going to put in 240 grams of peanut butter. And this is just a lot easier way to measure my peanut butter by weight instead of by volume. So we have different ways that we might measure something, right? So let's see. I'm up to, that was 243. I'm going to call that close enough for my peanut butter cookies. All right. So now I have 243 grams of peanut butter. My third ingredient in 3-ingredient peanut butter cookies is 1 egg. I'm going to crack in 1 egg, and I am done. Just need to clean off my fingers. So I can just mix up these cookies, and I will then roll them into balls, do the little crisscross with a fork, and it'll make a dozen big peanut butter cookies. So that's it. What does this have to do with chemistry, though? Well, in chemistry, we just in the last couple of weeks have been making chemical equations, right? We've been mixing chemicals together, seeing how they react, and getting something out on the other end. So when we do a chemical reaction, how many reactants do we want to put in to get something out on the other side? Well, I wanted to use an example of a reaction today. So one really common, so there's my peanut butter cookies. I get to enjoy that when we're done. One common reaction that I thought I'd use an example will show up on your screen, and that's when we mix calcium oxide with water, and what we get out of that is calcium hydroxide. Calcium hydroxide is commonly called lime, and lime is used really commonly all over for certain things that you've heard of. For example, concrete uses a lot of lime. It's used in water treatment to filter out certain things, or even in food. We use lime in pickling, so it gives the pickles what they want, or even in like tortillas. They use lime in the water that you make tortillas out of to give it the right texture. So that calcium hydroxide is a really common chemical. So the formula for calcium hydroxide, to get it, is you mix 1 molecule of calcium oxide, CaO, with 1 molecule of water to get 1 molecule of calcium hydroxide, CaOH2. So if I want to get 1 molecule of calcium oxide with 1 molecule of water, how do I get the right molecules of each? I'm going to use an example for you here. let's say that my calcium oxide, it's a powder, it's in a solid form. So let's pretend this flour is calcium oxide. Let's say if I want 1 molecule, maybe I could just say that's like 1 cup. If I wanted to measure it by cups, if I say I have a cup of it in powder form, could I mix that with 1 cup of water? Would that be the right number of molecules of each one? Or would I have extra? How do I know? How many molecules of calcium oxide would be in a cup of calcium oxide? Do you know? Well, we kind of need a new unit. That's the problem, is we don't really know. Because in solid form, it's totally different than like the water in liquid form. How many molecules are in a cup of water? Well, it's not really a good way to measure molecules. So what we discover is if we want to measure the right amount of things together in chemistry, we need a new unit. And what we came up with is a number that we can say if we mix that number of something together, we have just the right amount. And that number is a mole. And a mole of something is a whole lot. And we say 1 mole of that whatever is 6.02 times 10 to the 23rd of that number of atoms of whatever is 1 mole of that amount of something. So, I mean, let me say that again. 6.02 times 10 to the 23rd atoms of, say, oxygen, or that many molecules of, say, calcium oxide will equal a mole of calcium oxide. And a mole of calcium oxide, we can figure out the weight of in grams using our periodic table and the atomic weights of the different components of it. You will learn how to do that next week, but this week we're just learning about moles and about the guy we named that number after, that number 6.02 times 10 to the 23rd, and that's Avogadro. So you will watch some more videos and learn a whole bunch more about Avogadro. We gave him the name of that number because he was the first one who theorized about individual molecules making up the same amount of space in gases. So learn about him in the rest of the videos, and you'll learn about this new unit and how it's super useful to us. Have a great time.